Alright, so we missed a few classes and we'll again miss another class tomorrow, day after tomorrow, right? It's a government holiday, so we'll have to do something about the classes that we have missed. And maybe not this week because I have to arrange makeup for my artificial intelligence class, and I haven't managed to do that yet. So maybe we will have a makeup of that on Friday, but we'll see. So I'll let you know through Google Classroom what options we got, and then you can vote on it. Now, coming back to the content, we have covered file I/O. We have this sort of assignment ready. We talked about the assignment in our lectures, right? So we have a demo of it already, and I think you can get started with that already. In today's class, though, we will focus on something different, something we haven't talked about yet. It's going to be about databases. So some of the problems that you may have noticed about file input-output is that it's very much localized. Okay, so we know how to deal with file I/O, but that's not going to solve the problems, because if you think about the banking software that we are trying to make, we may need multiple tellers to work on the system at the same time. If you walk into any bank, you'll see that there are a number of booths. It's not just a single teller. There can be like 5 or 6 tellers that are sitting at their desk, and then you can get the service from anyone. So all those people, they will need access to those files. So if you maintain all the client records and all the transaction histories in 2 different files, you need to have copies of them in all the places. Now what if I make some changes? If I go to one teller and do some transaction, that means the file gets updated rather, and then I go to another teller for another transaction. Do they get the same updated copy? That's a problem, right? Because files, they reside on hard drives and they don't get replicated by the. You could say that they're using some service like Dropbox, okay, where you can do file sharing. But for those of us who have used Dropbox, you see that if multiple people are working on the same file at the same time, you will have conflicted copies. You have multiple versions of the same thing in that scenario. So you don't want that. I mean, definitely a good solution is now provided by Google and other cloud service providers. Like you could use Google Doc for editing a file simultaneously, but that doesn't really solve this problem over here because we're not going to use cloud services at this point. Okay. We're not going to keep our accounts.txt file as a Google Doc, for example, because we cannot access that directly from the internet. Yes, you can through something called some API, but we don't know that yet. I mean, at this level, maybe it's too difficult for you guys. Databases, on the other hand, gives us a lot more flexibility because they can reside at a central location. See, we may have a lot of complaints about the existing registration system, everything else, but it actually resides at a central location, and that allows us to access it remotely. So we can do our self-advising from home. We don't have to come to university because the database is kept in a central place, and all us teachers and students alike, we can access that system. We can log into the system, access the data, do whatever we need, whatever is given access to us. We can do that because databases, they work at a central location. They're also secure. So if you don't know the username and password, you cannot access that. That's another nice benefit. But the best benefits that we get out of databases is that they are optimized for searching or inserting data, that you can manage a lot of data and you can search through that very fast, or you can insert data very fast. Whereas if you try to do the same thing within file, it can be problematic. Just a bit. কি কারণ কিছু দেখতে আজকে স্যার রেগুলার ক্লাস করলাম আমি মেকআপ না করি No, ঠিক আছে তাহলে আরেকবার একটু দেখি খোঁজ নিয়ে প্রোগ্রাম অফিসের থ্রুতে ঠিক আছে আমি দেখে রাখবো প্রোগ্রাম হ্যাঁ গত কয়েকদিনের জন্য যদি হয়তো আন্দোলনের সূচনা কিন্তু সেটা হ্যাঁ সেটাই আমি ওটাই বলতাম আর কি প্রোগ্রাম থেকে আমি নেক্সট স্টেপে করবো আর কি সেটাই ওই যে পরে গার্জেন এসে তো সেই কমপ্লিটলি আমি করবো আর কি জানালেন না যে তারা আসলে না জানতে পারবে ঠিক আছে আমি যে প্রসেস ক্লাস থেকে শেষ করে সরি স্যার Sorry about that interruption. So what I was saying is that databases, they're secure, they're in a central location, but the best thing about it is that it lets us search really very fast. And to show you why that makes a difference, let me pull up the File.io based solution that we have already. It's taking ages. Okay, so NetBeans projects, and we have our, where is this assignment? Alright, so here you can see that we have written down all our account information in one file that's called accounts.txt. We have the account number, account name, address, and balance. So for each account we got 4 lines, and if I ask you how many clients are from a particular area, let's say from Dhaka, can we search through this entire information quite fast? The answer is straightforward no, because we have to read each and every line. Okay? So we have to read the account number, the account name, the balance. None of it relates to the address, and then we have to search through that. However, a better arrangement can be made if you just go for a tabular approach. If you had rows and columns, things would be so much better. Let's say we have account number, account name, address, and balance, all written in columns, one after another. Okay, so for each entry like that, let's say we have account number 3, the account name is Ashikur Rahman. I don't know what it is, but let's say we have one such entry for one client. The next client we can put in another row, that's going to be another record, and we will have another record, and it goes like that. So if you're going to search through the addresses, you don't have to look at the entire thing anymore. You can only search through that column. So this tabular view is actually a much better view for searching or inserting data compared to the flat view that we have in a text file. Okay, this is much worse. Okay, because it's hard to look for any particular information, or it's hard to change anything, because if you make changes over here, if you have a longer address, that would affect everything that's underneath. So what we did in our assignment demo, we erased everything and we wrote the entire thing back just to change one thing, which is bad. However, if you had a tabular entry, so for Ashik sir, he was living in Notun Bazar for 12 years or more, I think. Then he moved to Shantinagor. So if I wanted to change this thing, this one thing, I wouldn't have to affect any of the data. I'd just go to this cell, identify it by a row and column, and then change the entry right here. So this view right here, the tabular view, that's what we get in relational database management systems. Let me write the name down. What we are talking about is databases today. Okay, and we can have multiple databases for many different purposes. There are many different ways of managing databases. These are called DBMS, database management systems. There are a whole lot of them, and one particular way of representing data in database management systems is done through RDBMS, which stands for relational DBMS, right? So we'll see what this relational database management systems mean and what are the features. We also have something called NoSQLs. I'm not going to talk about it, but it's getting popular these days. Just to mention the name right there. I guess most of you have heard about the database management systems, at least some of the names. They're pretty popular. So something like Oracle, maybe you have heard about this name. Oracle has their own database management system. MySQL, you may have heard about their name as well. Microsoft has their own SQL Server. Okay. So there's also PostgreSQL, and there are a bunch more. Right? There's a huge list of database management system. They have their own advantages. They have their own client base. They're using in this way. So what we're going to do in this course is that I will introduce MySQL to you. It's easy to configure. It's easy to create tables there. but you can easily move into Oracle or Microsoft SQL Server. See, the nice thing about all these relational database management system is that they have a common language to talk to. Okay. See, in our programming language, we got C, C++, Java, we got Python. There are certain differences in terms of syntax, but these database management system, they run through something called a structured query language. And the beauty of it is that the structured query language is very much natural. It's easy to write. If you get the hang of it, it's easy to adapt. It's close to English already, this SQL. And another big benefit is that the same SQL can be applied to all these database management systems. For all relational database management system, you have the same thing. So if you learn MySQL, it's easy to take that same knowledge and apply that into Oracle. Yes, there are many other administrative issues, there are many configurations that are different, but the actual query, how to get data, how to insert data, that's actually the same, because they all rely on structured query language. Now, in today's class, maybe I won't be creating the databases to start with, but we will talk about a design first, and then we can move on to how we can create those things, what are the syntaxes, how we can create a database, how we can insert data, and all that. But to start with, maybe that's not too difficult. So let me delete this. And just as we have started our coding with UML class diagrams, here I'd like to start with something that's called ER diagrams. So let me write the name down. ER diagrams, that stands for Entity Relationship Diagram. It's the core design for any relational database that you're going to design. And since we're talking about the banking thing, banking software that we're going to build, I'll keep my discussion around it, but we can talk about any case, and then we can design an entity relationship diagram for that. Okay. I'll try to bring in different examples so that you can get the idea for different domains. See, over here, if you look at the data that we store about a bank account, is we store the account number, the account name, the address, and the balance. These are the four things, right? If you talk about a student, for each student, we will be keeping their student ID, student name, student's address, phone number, father's name, mother's name, what else? Their educational background, what was their HSC result, which school and college they were from, and all these details. You have to fill out that form, right? So all these information needs to be stored somewhere, and that somewhere is the database. That's what we do. So in this particular design, what we do is whenever we need to store information about a particular thing, we call that an entity. And this is marked over here with E. You just drop it over here. So for now, the account can be an entity. What are the things we store about an account again? The number, name, the address, and the balance, right? So those things, these are called the attributes, and these are marked in oval. So in oval shape, you say we have to store the account number. So that's one thing. We have to store the name. That's another thing. Address, that's there, and there is also the balance. Is that thing clear? Okay. All right. So what we do is that we join them, obviously. We connect them with lines with the entity. And that's a very high level diagram. It's not for implementation, but it's for getting the idea across. When you're talking to your team, if you look at a diagram like this, that tells you that you have to create an entity. So this account is a thing. You have to store information about that thing in your database. What are the things that you store about this thing? You store the number, you store the name, you store the address, and you store the balance. That's all you're saying. Okay. Is that clear? So let us look at some other examples, just to make sure that we got this idea right. Okay, so that's one. So let us talk about students as we were doing. For a student to be an entity, I'm not going to list all of them, but let me list some of the most obvious ones. We need to store the ID. We need to know the name of the student, right? We need to know the address of the student. So let me limit it to these three, but there can be a whole lot more. So that can be a student entity, and we have these three attributes. In terms of a tabular view, we can imagine that we will have a ID column, we will have a name column, and obviously an address column. And for each of the rows, we will have entry for one student at a time. Okay. What do the students do? In our university, what do they do? Yeah, they study. Well, they also sing and dance and they sleep. But that's a different story. And that's not the purpose of this database. So, since we're talking about studying, right, they register for what? They register for courses. And course can be another such entity. And if you'd ask, what are the things we need to store about each and every course, what comes to your mind? We have course code. What else? The name of the course, which we say that's the title of the course, that's course title. And also, how many credits is that course worth? So yeah, those are all good answers, and we can write that in this form, that we have course code, we have a title, and we got credits. All right, so let me move them out a bit. This is not joined. All right, so we got student and we got course. But these are related concepts. Okay. I'm not going to open up courses if there are no students they're going to register for it. And students, they're not going to exist over here if they're not going to study. So they're very much related. What's the relationship between a student and a course? There are many ways to show that, but what you can relate to probably is the students, they register for courses, right? We have a self-advising and then followed by a entire registration process. So we can say that these students, and we have a relationship, that's a diamond shape right there. students they register 4 courses. So you can এক্সামশিপগুলোতে প্রত্যেক সমস্যা ছিল যে নেটওয়ার্কের সমস্যা হচ্ছে আমরা এটা একটা কম্পিউটার সফটওয়্যার আছে তো এটা জেনারেট করার জন্য ওই করতে পারিনি আমি দেখি এটা পাঠিয়ে দেবো মানে আজকে আমাদের কোয়েশ্চেনগুলো আসা শুরু হয়েছে কোয়েশ্চেন বেশিরভাগ দেখলাম জমা করে যাচ্ছে আমাদের এখানে মডারেশনের জন্য ওগুলো আমরা পাস করে দিয়েছি স্কেজুল করে দিয়ে দিল ল্যাবেরটা কি আপনার কাছে চলে গেছে ল্যাবেরটা আলাদা ঠিক আছে আমি এখানে খোঁজ নিচ্ছি আমার কাছে Sorry about that interruption again. Alright, so our students they register for courses and that can be shown with this diamond that we got and we join them together to show that they are connected. So it's a connected concept. Students they register for courses. It has nothing to do with the bank account, it's a separate example, but it's just there. Okay. So in relational database management system, this is what we start with. In relational database, we start with entities and we got 2 entities over here. They are related, so that's why this is entity relationship diagram. Describes the relationship between 2 entities. Okay. And if you have that diagram nicely prepared, it's easy to go to the next step where you actually design another diagram, which is called the schema diagram. And once you have that prepared, you actually go for the implementation. You write some code that creates the database tables for you. You insert data, you can query them, you can get it back into your Java software. So what you'd have to understand that this is a totally separate piece. Okay? Your Java software has no relationship with this apparently. This will stand alone in a separate place and your Java software will communicate with it to maybe insert data or to get data. That's the basic operation. You don't have to have Java knowledge to create databases. Okay? And you also don't have to have database knowledge to be a Java programmer, but nowadays like you need all these concepts together. We're going to do full stack programming. Okay? In reality, like if you're working for a big firm, there will be specific people who deal with databases, there will be database administrators, then there will be other people who write the programs, there will be the developers, the programmers, the software engineers, right? So at this point, I mean, it's hard to tell which path you're going to take. So if databases interest you more, maybe that's the direction you want to be working towards, like be a database administrator. But if you want to stick with programming, yes, definitely you can do that as well. So now is the time to explore all these possibilities. And this is where we talk about databases right now. We're not going to talk about Java, maybe not in this class. Maybe in the next class, I'll show you how they're related. So some more things that you can answer right from here. That when students they register for a course, how many courses can one student register for? Each semester, a student can register for, let's say, 3 courses or 4 courses or 5 or 6. It depends, right? If you have lab courses, maybe you register for more courses. If you have only theory, maybe you register for less. So for one student, we may have n number of courses. N simply means many, right? One student can have many courses. So that's one way of looking at it. If I look at it the other way, if I look at a single course, how many students can one course have? Many, right? And on surface, like in this course, I see that there are probably 30 students registered, but I know also 30 students in class. So that's the thing, right? Like there can be 10, 15, 20, 30, or 28, whatever number we can say. So over here, for one course, we can have many students. So that's looking at it in another direction. But we have to look at both these things at the same time. And this is how we do that. Many students, they register for many courses. That's the M is to N, many to many relationship. In entity relationship diagram, there can be other scenarios. Let me look at another very simple case. All right. We got many programs in Southeastern University and also in other universities. Each of these programs, they have some sort of code, and they have a title. So for example, what's the title for our program? No, the name of the program that you enroll for when you join Southeastern University. BSc in CSE, that's the name of the program. So that's the title, right? Now a student can enroll for how many programs? For one. So one student enrolls for one program. Okay, one student enrolls for one program. Okay, let me rotate this. However, for one program, how many students do we have? Many students. So if you're going from this way to that way, for one program, we may have many students. Okay. See, how does that look like? For one program, we got many students. Many students belong to one program. Okay. And over here, we read it as many students register for many courses. Okay. So there can be different types of relationship based on the numbers. These numbers, we call them cardinality. Okay. So if I open it in DIA, you'll see that this term is written, cardinality. Okay. That tells you how many participants are there. So for one program, there are N participants. That's the cardinality over here for this relationship. And this end, we have 1. So over here, we have M cardinality, we have N cardinality. That tells you how many participants are there. So there are 3 types of cardinality, and I'm showing 2 of these over here. That's one to many to many, and there is another one called one to one. Okay, all these things you'll learn in more details when you go to the database course. This is not a database course, that's why I can't go into details. But these are quite interesting things, and if you get the hang of it, if you get the hang of the design itself, life becomes much more easier to go with the next steps, how to create the database, you'd understand it all. So that has to be the first step when you visualize this thing, that you're given a problem, and the questions that you'd be asking as a database administrator: what sort of data am I storing? Okay. So what sort of data am I storing for students? That would answer you what are the attributes you need over here. You'd ask what sort of data you need for courses. They're going to be the attributes over here. And then the next obvious question: how is the student related to the course? The students, they register for course. Okay. Is there any relationship between the program and the course. Yes, the courses, they belong to a particular program, right? For example, we have CSE 1011 that belongs to CSE, BSc and CSE. In ideal scenario, actually, many programs can have the same course. And we do see the same thing over here also, like ENG 1001, ENG 1002. These courses are common to all of the programs. So more than one program can have the same course, and one program can have many courses. So that tells you that there is a relationship between the program and the courses, and that's again a many-to-many relationship. So if I were to draw a diamond over here, that's for the relationship. I could draw one just like that. So the entities, they store data, and the relationship, they tells us how two entities are related to one another. Okay? If you understand this bit, you can sort of see that it doesn't really give you much information, but it's a very easy thing to communicate with, because anyone who got the basics right, they know that the rectangular things, they're entities. These are the things you're going to store. And the diamond shape, they're the relationship between two things. If you know that bit, it's very easy to read this thing. Okay? Anyone can sort of understand this. So this is actually a very nice diagram that you can take to your clients, or you can have it in a team meeting. You can talk about the initial design, but this is not going to take you that far. See, if I were to write a Java class for a student, okay, and decide that what are the attributes I need for a student. I need the ID, I need the name, and the address. Okay, so you can probably relate these two concepts together. That for UML class diagrams, we decided on the attributes, and these attributes are over here as well, along with the entity. Entities have attributes. Our classes, they also have attributes. But is this thing enough for you to write a Java program? Why not? There is no type defined for any of this. You don't know what this ID is, whether this is a string or integer or long. You don't know that. You don't know about this name, whether this is a string or integer. Well, common sense would obviously say that these two has to be a string, but unless you write it down, your Java program is not going to write itself. Okay, so you have to know what is the type, and that's something we do. Over here, we say that the type of this thing is, let's say this is long, this is a string, and also this is a string. And we don't stop right there. We also change the visibility to private to protect our data. That's encapsulation, right? So we have seen this before. Now it's more like it that you can start writing a Java class. You write class student, private long ID, private string name. You can start writing your program from there. So you have to have some more details to start writing your Java program. Okay. What are the things that a student can do? Can be the operations. So we're going to write some operations like get ID, that's going to return a long for you. We can have a get name, that's going to return a string for you. And also, let's say we have get GPA that returns a double for you, which is not possible at this point, but why not write that? So these are the operations, these are the attributes, this is the class name right here. But if you look at the name of the operations, do we get the definitions of that already? Like, do we know how this get GPA works? Do we know the exact statements? No, we only know the name. So this itself is maybe not enough to write the Java class, but it at least gives us a summary of it. What are the attributes you got? What are the operations you got? So that's a nice high-level overview of the entire class. That's what a diagram does, right? If you need to look at the code, you look at the code. If you need to know what are the things that are there in the class, you can just look at a diagram because that's easier to understand. So the point that I'm trying to make over here, in an ER diagram, this will not create the database for you, but this is a start. This is the design that you're talking about. And as you'd see that we didn't have the answers unless we wrote down the types over here, the long, the string, and string. We didn't know exactly how to write it. Just by looking at the ER diagram, we cannot create a database. Okay? You have to take it to the next step. So this is the first thing. This ER diagram is a start. That's the first thing. But you have to take that to the next level. Okay, let me move it out because it's a different concept. Let me focus on the ER diagram for now. So this relationship, let me just call has. A program has courses, and I need the name for this. Okay, many program have many courses. That's the idea that I'm presenting over here. Okay, so we got 1, 2, 3 entities, and we got 1, 2, 3 relationship. There is no relationship between the numbers of these. You can have more relationships over here. You can have more entities that may be related, that may not be related, but that's what it is. All right. So a few things about this ER diagram, like you have already seen that the rectangles are for entities, the diamonds are for relationship, the ovals, they are for the attributes. Okay, so we know the names right now. One thing is special about some of these attributes. See, this thing we call a key. This ID is a key. It's a unique number. I mean, I can have two students with the same name. I can have two students that reside in the same address. If you're siblings or if you're living in a mess, you have the same address. You can definitely have the same name, but you cannot have the same ID. So ID is a unique identifier for each and every student. Each student has their own ID. If you look at the course, do we have any such thing? Two courses can have the same credits. CSE 2015, that's a 3-credit course. C course, CSE 101, that's also a 3-credit course. Yes, the title itself has to be different. However, there is an anomaly. Let me show you if I can. Okay, all right. Right. That was so smart. I'll change that. Okay, all right. What I wanted to show you guys is this thing that we have two courses with the same name, CSE 1031, that's numerical methods, and CSE 1032, that is also numerical methods. This one's for CSE. This code, CSE 1032, this one's for EEE department. They have a slightly different curriculum, but that's probably a 2-credit course. They used a different course code. Okay. So course titles, they're not unique either. The course titles, they're not unique either. The course codes, they're the unique things. The credits, they can be the same. The title, they can be the same. But the course codes, you won't find 2 courses with the same course code. So that has to be the key in here. Okay. So what's a key? A key is a thing that uniquely identifies a record. Is that clear? Okay. All right. So what about program? Program has a code and a title, and well, the code and the title, both of them, they should be unique. But for simplicity, let's just say that, yeah, I can have 2 programs with the same title, but with different programs. Well, actually, we do have that already. We have a weekend program with the same syllabus and everything. That's also BSc in CSE. A regular one is also BSc in CSE. That's the title. But the code may be different. We will use a different code or a different number for that. Okay. So is this example clear? That these are all the attributes, but some of these attributes are special attributes. We call them the key attributes, which lets us uniquely identify a particular record. And to show you how it may look like in terms of a tabular view, let me just do it right here. So let's say I'll do it for the course. We will have a course table. We have course code, course title, and credits, right? So something like CSE 2015, the title of that can be programming language to Java. The credit hours is 3. CSE 1021, that's our discrete math. That's also a 3-credit course. CSE 2016, that's going to be Java Lab, and that's that. Okay, so right here, what you can see is that we have this course code. Okay. So we got this course code over here, we got a course title, and we got credits all in one place. But right here we have this underline that tells you that this is the unique thing. If you know the course code, you can identify this thing, but we may have the same course title in multiple rows. So that's the key thing. And this is how exactly you will have these things in databases. This is not a database, by the way. This is a spreadsheet. But a database will have a similar view. We will have tables for each and every entities. So this course entity, it will be a table eventually. But in order to create the table, we have to know what type of data we're storing in each and every column. And we need to know that. So is this clear till now? And let us then answer the next obvious question that we don't have answer for. We know that for a course we need course code, we need course title, we need credits, but we do not have any sense of data type at all. So this is where we go to schema diagrams, and that's probably in database. Yeah, that's the schema. So let me drop it right here. You see, as soon as we do that, it says table. So we're going to give it a name. This is going to be for course. And the attributes, What are the attributes we need to store for our course? We need the code. We need the title. We need the credits. So this is how it looks like: code, title, and credits. Okay, it's similar to the class diagram, but it doesn't have the third box because this is about storing data. This is not about operations. A class has all these things. A class has the data members as well as the operations, the attributes and the operations. But in database, we only talk about the data. We don't talk about the operations. That's a different story. Okay, so what is the type of the course code? CAC 2015, that's a course code, right? It has numbers, it has letters, so it has to be a string. So you can say that this is a string. However, the problem with this is that there is no such type in SQL called string. In databases, since we're talking about storing data, we are very picky about it. We have the same concept as string, but we call that var char. Var char stands for variable characters. How many characters do you need for a course code? You have to put a upper limit to that. And the upper limit over here, I've just randomly put 8 over here. Well, not really randomly, I know that for a fact. For example, this course code, for this course, CAC 2015, we got 7 characters. Okay. ENG 1001, that's also 7 characters. Previously, we had 3-digit codes. So the one that we had for Java was probably CAC 132. So that was a 6-letter course code. Okay. But then we have course codes like math 2015. That's for linear algebra. So MATH, that's 4. 2015, 4 again. So 8 characters. That's the max. Okay. From Stat 2011, I think that's another course. So there can be course codes that take 8 letters, there can be course codes that take 6 letters or 7 letters, but nothing more than 8. That's what it says. It varies. Okay. The name of the course, that's the title of the course. What can be the maximum length for a course title? Okay. I don't know, right? But I mean, you can just look at it. There are some long names, there are some short names. So operating system is maybe not a long name, but this one is a longer name, right? So depending on the client's requirement, you decide on this. I'll just say that there won't be courses with more than 40 characters in their name. Okay. Now, I could definitely crank it up and say that a course title can have 4,000 characters. So what's the point of it? It's never going to use 4,000 characters. And you need to keep them low to optimize the database to make sure that it is efficient. So if you don't need extra characters, you just leave it there. How about credits? Yeah, I'll write double. The course codes, for each course we have credit hours, and for CSE you'd see 3 credit courses, you'd see 1 credit courses for the labs, 3 credit for the theory, and there's nothing else. But for some of the department, for example, for the textiles engineering, they have 1.5 credits for the lab courses. Okay, so there can be certain departments that they have the different requirements, and accordingly you adjust those. This course code is the primary key. It uniquely identifies a particular course, so you mark that as primary key. So this actually is much more useful than this diagram. Okay, gives you the same sort of information that you have You have the course code, you have the title, and you have the credits. And this one is underlined. That tells you that this is the key, which you can already see over here. The difference, though, that this guy over in the entity relationship diagram didn't have any data information, that what type of data it is. But now we can answer that. We can say that the course code can be maximum 8 characters long. We know that for a fact. This thing is called the schema diagram. I mean, it's a separate thing. You will draw it separately. I just put this box right over here so that we can compare what we have. So this is the initial design. This ER diagram is the initial design. And once you do this ER diagram, you go ahead and start drawing a separate diagram. That's the schema diagram. So let me write the names down. ER diagram is this one. And over here we have the schema diagram. Okay. Now, once you have the schema diagram ready, you're good to go with the next step, which is actually implementation of the database. You open up your terminal or your whatever tool you're using to create the database, and you just write some codes that will create the database, the tables, and everything for you based on this design. Okay? So you need to understand the relationship between these two things. So what we're going to do, I'm not going to go into coding in this class, writing the actual database code, but we need to set this up right. So for now that we got it for the course, and let us just quickly do it for the student so that we can establish some sort of relationship between them. So just like course, we can, let me copy paste this. It's going to be a little bit faster. We need another table for student, right? For student, what are the things we store? ID, which is a long. And for title, well, we got name. What's the longest name? Okay, so I'm going to take a risk, all right? I'm not really good with hiding passwords from you guys, but AJ, was that 6? Alright, so what I'm trying to do here, I hope I don't butcher this one and reveal the password to you. I'm going to connect to our database and I'll try to find out the longest name that we got. Okay. Just to know what sort of things we're dealing with. So, as a password. Okay, so I'm trying to connect to our server. So 17.254. Okay. All right. So the thing that I'm doing right now, this is what we do in SQL, structured query language. So when I say use USS, that means that I'm going to use a particular database. There are a lot of databases hosted on the same machine, but I'm using one particular one over here. And then you'd see that this is very easy. I can look at the student table. Let's say I want to know the ID and name of all the students of Southeast University. I can do so quite easily. Select ID, name from student. And as you'd see that we have record of 52,239 students right in here. Okay. All right, so some of these names are long, some of them are not. I can know the length of a student's name like that, and maybe I want to see the names that are quite long, like where length of the name is more than, let's say, 30 characters. There shouldn't be too many names that have more than 30 characters, but I'm actually wrong. There are 243 such names. So let me crank it up. Okay. No, we actually have longer than that. We got a name that's 56 characters long. I'm not going to try to pronounce that. It is what it is. Well, the reason that I wanted to show you that is that it gives me an opportunity to show you how to write this thing. See, the codes that we're going to write, they're not really complicated. I want to get something, right? I'm selecting what? ID, name, and the name length. So from where? From the student table, where the length is greater than a particular limit. So it's actually easier than writing Java programs or C++ programs, easier than that. Okay, so that's the name, and then we have something called address. Okay, I could actually get the address of all the students as well. So describe student. I don't know the column name. Oh, that's that. One address field is called home, the other one's called permanent. So instead of address, I'd say home to get the home address, or permanent for the permanent address. Yeah. People from Narayanganj have longer names, it seems. Or maybe from the cantonment. Okay. So the address cannot be double, it has to be varchar. So maybe like 100 characters for the address. Okay. So this is how we create the tables. We got database tables. We got a student table, we got a course table, right? Now, this is quite easy to understand. If you look at this spreadsheet, if you look at this student table right here, we got the course code, course, I couldn't spell that. Right, that's better. So course title and the credits. Now, if I wanted to know which students are registered for this particular course, how will I know that? Right now, there is no way to know which students are registered for this particular course TSC2015. So you can imagine that we will have another table for the student where we have student ID, student name, and the address, but then we will not have any such column for the students. Because if I wanted to keep all these students that are registered for this course, what do I do? For each of these students, I could write them all in one place in comma separated list. Okay, I could write 30 names in here in one line, but that's going to be a very bad practice, because if I wanted to know if a particular student is present in one of these courses, that would be difficult to search. That's the reason we came with these separate columns, and I can definitely not create 30 separate columns for each student along with this. That's going to be a very bad design. And in the same way, let me just write this down. Say we got a student table, we will have ID, name, and address, right? That's for the student. We will have all the students one after another like this, but we cannot have the course entry right here. There is no point, because for each student there will be 5 or 6 entries for the courses. However many courses you took, I have to keep spaces for that. So the student who took 3 courses, we will be wasting 2 cells for them, because there won't be any such thing. If I say that all the students are taking 5 courses, there will be students who don't take 5 courses. There will be students who are dropping this semester, so they will have all the cells that are being wasted. In databases, we don't waste space, not in the relational design at least. So we have a problem right here that we cannot show this thing right away. So what we do is that when we have a relationship like this, that's many to many, what we do instead is we create a new thing, a new table, and we call that registration. So for each registration, we need to know the student ID, which is a long. We also need what? Course code, which is varchar 8. Now these two things can be tied together. Student ID goes over here, actually the other way. For each student, you will have many registration records, right? For one, there will be many registration records. For one course, there will also be many registration records. Is this thing clear? So we're creating a new table to record this thing. So in this intermediate table, you'll have many such rows. If you register for 5 courses, you'll have the your ID 5 times, and then the course code. This is exactly how it is in our databases as well. So that's actually written in temp reg, something called temp reg, temporary registration. There is a table like that. Let me show you one quick example. Can I get any volunteer who'd share his ID with me or her ID with me? Anyone? Just a bit. Select everything that's star from temp reg, where temp reg.student ID equal to 2016 1023 4 5 6 7 44. Okay, so I got the registration ID, student ID, offered ID. You don't understand offered ID yet, but we got the credit, we got semester ID, course code, and program ID and type. So if you're looking at this semester's registration, you see that these are the courses that you registered for. So it's right here. So it's all from our actual database that you can see how the records are kept. We have the student ID, which is over here, and we got the course code, which is here. We don't have the student's name. If I need to know who is this student, I can get that information from a separate table, from a student table. I don't see what this CSE 1034 stands for. But that's not a problem. I can go to the course table to look at this name. Okay? So in databases, this is exactly how things are kept, so that we can look up something quite easily. I mean, just to answer this question, CSE 1034, let us just have a quick look at it. Like, if I need to know what are the different courses, you could say select star from course, and you can see that there are like 2,449 courses, but I don't need all of them. Select star from course where code is equal to CSE 1034. Then I won't have all that. I only have data structures lab. Okay. If I needed to know who is that student with ID 20160000000044, I could find that out quite easily. But I have to look at the student table to find that information. I can find the home address, the phone number, and everything else, whatever is in our database. So I can do that. Okay, is this thing clear where we are going? So we'll be working with something like this, but in order to go here, in order to write those codes, you need to understand the design first. And that was the basic of what we did before as well, that we started off with the design, and then we expand on it. We'll be writing the codes that will create these databases and everything else. Okay? Any question about any of these things? So from this point onwards, this is what we'll be focusing on, that we'll be creating databases for our applications, because most applications these days, they need some sort of databases. Even if you talk about computer games or mobile phone games, there's also a database for that. Yeah. Like, I mean, if you're playing Clash of Clans, how do you know what clan members you got? Who are your friends? How do you know that? They keep a central database for that. Your phone, when you connect to the internet, communicates, it synchronizes, gets the data from there. Other games, like shooter games, maybe you have some top score, some high scores. That's also a database. Keep those things in place. And obviously, like if you want to build a registration system, that needs a database. If you want to build a banking software, that also needs a database. All right. So let me save this thing so that I can use it the next day. databases. So that's that. By the way, when's our assignment due? 29th of this month, right?